Hello everyone, good morning. Today we are going to discuss about basics of networking. Let's discuss about networking basics. So yesterday we had a discussion about what is network and what is networking. So network is nothing but interconnection of two or more devices is called as a network. Network is nothing but interconnection of two or more devices. So two or more devices means computers. Interconnected, each computer is called networking. So let's say this is switch. This is switch. Switch is to form the network. This is switch. Okay. Let's say this is switch. So this switch, all the computers in the network, all the computers, let's say these boxes are computers, PCs, PC. Okay. So likewise, we have many pieces in the network. So these are all pieces. So what the switches do? Switch form the network. Switch form the network. So this piece is connected to switch. This is the network. Sorry, this is the network. So interconnection of two or more devices is called a network. So now the network, this PC can communicate this PC and this PC communicate this PC. So all those PCs communicate vice versa. Communicate vice versa. So in the network, from any PC to any PC, you can exchange the data, you can share the resources, uh, you can communicate across the network. Any PC can communicate in the network. Okay. So the communication between two or more interconnected devices is called networking. So networking is maintaining, troubleshooting, managing the network. That is called networking. So establishing the connection between devices with the help of hub, switch, access points for data communication. So switch is a device, is a network device which helps to communicate all the computers, let's say all the devices, communicate all the devices. So hub is a older technology. Now we are not using hub. Why we are not using hub? Let's have a little glance what is hub. So why we are stopping using hub and why we are started using switch. So in the communication, when compared to switch, hub is very slow, very slow. Let's same sub hub also connects. Let's say this is hub. Okay, hub. This is hub. Similar way, we can interconnect the devices using hub, and the hub is communicate multiple computing devices. So hub also forms the network. But what is the difference between hub and switch here is, for example, this PC want to communicate this PC. Okay, want to communicate this PC, but hub doesn't have a memory. Hub doesn't have a memory. Hub doesn't have a memory. Switch has. Switch has memory. So if you lost the memory, any human or any animal or so cannot recognize others, right? So similarly, hub doesn't have a memory. Basically, hub doesn't have a memory. So switch has a memory. That is the reason switch is faster than hub. So what is memory? Maybe you're getting confused, right? So for example, this PC want to communicate this PC, or this PC want to send a data, or this PC want to share some information to this PC or any PC in the network. So usually the PC send a request to this PC, but the request going to hub. Initially, the request will go to hub. Hub as doesn't have a memory, so hub usually check with each PC. Are you, for example, let's say this is PC1. Okay, this is PC5. So PC1 sending data or info or sharing the information to PC5. Okay, information to PC5. But what hub do when the PC is sending a request or sending a data to PC5? The hub used to check with each PC in the network, because the hub doesn't know where the PC5 is. Hub doesn't know where the PC5 is. So PC one request, taking the request and checking with each computer in the network. So hence the network is slow. Okay. But coming to switch, what the switch do? The switch grab all the information, all the MAC address, physical address. I already discussed yesterday. MAC or physical address. This is a unique address like our IMEI number. So each phone has a IMEI number, right? So likewise, each PC has a MAC address that is called physical address. So each physical address will store in switch memory, so that switch easily can understand if PC1 sending a request to PC5 what the switch do? Directly send a request to PC5. There is no delay to sending the data from PC1 to PC5, because the switch has address, MAC address of all the PCs in switch. So switch is sending directly to PC5, because switch knows that PC1 sending to PC5, because the both MAC address has the in switch memory, so that easily can the request is going to send the request is going to PC5 directly without delay. So if the letter doesn't have an address, what will happen? That the letter will loop until get the address. So likewise here, all the addresses of PCs, I mean MAC address in switch memory. In hub, there is no memory in hub. So that is the reason hub doesn't store all this information. Instantly, who are sending the information, hub used to check all the PCs. Are you PC5? So hub used to, are you PC5? No. Oh, are you PC5? Yes. Okay, then drop the request or share the forward the information or share the information. So that is the reason we are stop using hub. We are stop using hub because it is very delay. Like, can you use the 2Z now? No, right? We are using 5Z now. So to match our fast, The network should match our speed. So nowadays we are not using hub anywhere. Nowhere we are using hub. Now everywhere we are using switch to form a network. Okay. So yesterday, sorry, yesterday we had a discussion about types of networks. Types of networks. Types of networks. So what are the types of networks? One is LAN, local area network. Okay. One is local area network, LAN. And second one is, you know, that Metropolitan Area Network, MAN. 1 minute. MAN, Metropolitan Area Network. Metropolitan Area Network. And third one is WAN, Wide Area Network. Wide Area Network. So these are the types of networks. So usually LAN, where we see LAN, it is a private network. We can call private network as well. We see offices, in offices, and your home, in your home. So nowadays, every home has a more than 3 or 4 laptops or 2 PCs and mobiles and Android TVs, all this. So every home is now a small LAN nowadays, not before. Nowadays, every home is a LAN, a small LAN, collection of laptops, desktops, mobiles, TVs, everywhere, and we are using internet, right? And we are operating many things in the home utilities using internet, right? Home. So these are all the local area networks. So this network, all the devices runs on all the devices runs on private IP address. Private IP. All the device runs on private IP. Then how they get the internet? So if they're on private network and private IP, the private IP cannot communicate a public network. So we cannot get the internet. So later I'll discuss how we will get internet on private networks. Okay. Next, Metropolitan Area Network. MAN. Metropolitan Area Network are used to connect networking devices that may span around the entire city. So if your office in a city which is having 2 or more branches which are interconnected, that is called MAN, Metropolitan Area Network. So this is also offices in different places in the city. So these offices are interconnected, called Metropolitan Area Network, MAN. So offices in different places in the city. So Bangalore is the best example for that, because we have many companies are located in different places in different areas, like HCL, TCS, Wipro, IBM. We can see Whitefield. We can see in uh, Martali. So many places, we can see the same companies in different places. I couldn't recall the locations. Even I worked more than 7 years in the city. Okay, so I have less memories like hub. Okay, coming to WAN, wide area network. Wide area, what is wide area network? Wide area network is a public network. We can call public network. We can call public network. So this is also called internet. In our layman language, we call internet. So if you call internet, that is the layman language, public network or WAN. Public network. We named WAN is a public network or WAN, wide area network. Okay, so also called in our language, like in layman language, internet. So WAN, wide area network, which connects two or more LANs present at the different geographical locations. So we are able to communicate from your place to across the country, across the world, like 183 or 185 countries. You can talk to anyone from your place to any country in the world. That is power of WAN, wide area network. That is also called public network. Okay, so this uses public IP address. This use private IP address, and also this use public and private IP address. See here we need to understand that in the private network, we use private IP address. In the public network, we use public IP address. Okay, so I will give you more insight about this. Don't worry. And coming to internet is a massive network of networks. Okay, in networking infrastructure, it is a big networking infrastructure. So it connects millions of computers together globally, forming a network in which any computer can communicate with any other computer as long as they are both connected to the internet. So now let's take an example. You are also sitting at your places. I'm also sitting at my place. So all the computers connected in this meeting, right? But if you check your computer, your computer using private IP address. Let's check my computer. ipconfig /all. I will tell you all these commands, don't worry. So ipconfig is the command to know your IP address in the system. Okay, so let's see. This is my IP address, private IP address. So how can I say, how did I say that this is private IP address, that is public IP address? I will tell you in upcoming class, today itself, I will tell you what is private IP address and what is public IP address. So, sir, all my computer using private IP address, but how did I get the internet? It's not magic. So there is a concept of NAT, network address translation. There is a concept of NAT, network address translation. Translators. See, for example, we've seen many translators, right? So if you don't know Hindi, if you know Telugu or if you know English, someone will translate to in Hindi what you're talking. We see in parliament, in assemblies, wherever you see the discussions are important in UNO. So there are many places where the translation is happening. Even if someone is visiting our country who doesn't know the English, for example, Russia is the best example. Putin never talked in English. So he need a translator to translate in his language. Likewise, here LAN, local area network, uses private IP address, but public network or WAN or internet, we can call this, uses public IP address. But how to communicate these two? The NAT. This NAT is communicate private IP to public IP and public IP to private IP. This is called network address translator. So this will do translate from public IP to private IP and private IP to public IP. Vice versa, this will translate. Hence, we are getting the internet. Okay. So coming to topologies. This is also we discussed yesterday. Topologies. Topology is nothing but design, network design. Network topology. Network topology. What are the network topology? We call bus. Okay. Bus. One minute. Bus. And second one is ring, and third one is star, and fourth one is mesh. Okay, these are the topologies. Topology is nothing but design. Topology is nothing but design. That's it. So who will design this? Are we are designing this, or someone will design this topology network design? Okay, so we are not designing these topologies. Then who are going to design this, or who design this? See, based on our devices, network devices, this network design will happen. So for example, if you are using devices, based on devices, the network design will form. Network design will form. Let's show you. Okay. Okay. So let's take our home. Okay. Let's take our home. Let's delete this. Let's take our home. So in every home nowadays, there is a Wi-Fi router, right? Wi-Fi router. Without Wi-Fi router, I guess. Wi-Fi router. Okay, before getting into this, let's say bus topology, ring topology, star topology, mesh topology. So yesterday we have a discussion that how the topologist looks like. One minute. Let me, I think we have a topologist. Not topology. Okay, no problem. Network topologies. There are many. Let's copy this. So these are the topologies. So we are using star topology. Bus, ring, mesh we are not using. And before these are the old designs or old topologies, which we are not using right now. We are using star topology more. So ring topology, what the ring topology do? Each computer connected together. See, this computer connected this computer connected this computer, all connected, interconnected. So for example, if this, let's say these circles are computers, if this want to send, if this computers want to send information to this computer, what will happen? From here, first the request will go to here, go to here. So this computer needs to cross all this and reach here. So it may take a lot of time. Okay. And for example, line. For example, this computer want to share the information to this computer. What will happen? This computer has to through all this computer's network and reach here. This is also slow. And for example, this one, okay, this computer want to send information to this computer. Then what will happen? The request will go to like this. Okay, so all fully connected or mesh. So mesh also like this. So due to other designs, the data will flow slow. Communication will get slow, right? Communication will get slow. So in the star topology, so for example, if you want to send information from here to here, what will happen? Let's say this is a Wi-Fi router or a switch. So the request go to directly to switch or router and then reaches this. So the traveling time is less. Data traveling time is, there is no hurdles, there is no hops, no stops, directly from here to here. So data is moving fast. Network is speed. Network speed is more. So, but who designed this? Are we going to design this? No, not needed. So if you buy network devices, based on your network devices, the network design will form. You no need to buy network design or you no need to design network. Okay. So for example, I'm just taking the example, our home, how our home network will design form. I mean, how our home network will form using network devices. This is the Wi-Fi router. So nowadays everyone knows that what is Wi-Fi router. So this Wi-Fi router connects internet, right? Let's say Wi-Fi router connects internet. Oh, where is the internet? This is the internet. Let's say make it small. This is the internet. All right. Internet. Or let's stop using internet. Public network WAN. Okay. This is WAN. Okay. So our router. So router having public IP address, because to communicate public network, router should have a public IP address. Public IP. Because router in a private network in our premises is connected to WAN, and router should have a public IP address. Then only connect to internet. Okay, that's fine. Now we connected to routers, Wi-Fi router. Am I right? How we are connecting? Few are, for example, let's say this is, oh my, 1 second. This is desktop. Let's say this is desktop. So usually desktop connected via cable. I mean PC. Let's say this is PC, personal computer. Okay. So personal computer connected via cable from Wi-Fi router to PC. And this is like tab. So Wi-Fi here. And this is mobile. Okay. And let's say this is TV, Android TV or TV. See, all devices, what Wi-Fi router is do? Wi-Fi router is sharing the internet. I mean, sharing the WAN network to all the devices in our home. But each device having private IP address, not public IP address, private IP. The who are giving the private IP, who are assigning the private IP? Wi-Fi router. Wi-Fi router assigning a private IP to all the devices in our home. But when you browse internet in any device, it will go to Wi-Fi router. For example, in mobile, I browse www.google.com. www.google.com. I browse this URL. So what will happen? The request will go to Wi-Fi router. Okay, Wi-Fi router. So Wi-Fi router, what the Wi-Fi router will do? Take the request. The request came from private IP address. So the private IP address cannot route or cannot communicate with the public IP, public network. So hence, the Wi-Fi router run NAT, network address translation. Network address translation. So this request on private IP address and the request convert to onto public IP address, and public IP address take the request to public network and get the response from the public network. So that responsibility will taken care by public IP address. So we have a single public IP address handling all the requests and taking the request to internet and get the response from the internet. So I browse google.com. So the request public IP address sent to Google server and get the response and take the response and send it to this device. And the request on public IP address convert to private IP address. So vice versa, here conversion will happen private to public, public to private. So when the request goes on private IP, it went on if the request go out on public IP. When request comes on public IP, it converts to private IP address. So this is called NATing. So now see, this is start topology. The request is going to Wi-Fi router and going out and coming back. And this is start topology. So how the network design informing because of our network devices. Based on the network device, your network topology will decide, not you, not anyone. Based on the function, how the network devices are functioning, based on the functioning, based on the behavior, based on the working style, the network design will form. Okay. So coming to, sorry. So we are all heard that NIC card. NIC card is very much important. So this all connections, the C, all connected because of NIC card. Without the NIC card, sorry, PC, coming to PCs. Coming to PC, without the NIC card, this personal computer cannot connect Wi-Fi router. Of course, we can connect on Wi-Fi, but Wi-Fi also needs a NIC card, right? Without the NIC card, we cannot get it, internet. So that is also important. So for every device, we have a NIC card, network interface card. We discussed yesterday this NIC, network interface card or controller. We can also call controller, network interface controller. We can call controller also. So NIC is the interface between computer and network. Okay, it is an interface. What is the interface? OS is an interface. Like for network, NIC card is the interface. For network, NIC card is a interface, because this NIC card is only translate from IP address to binary and signals. See, network is also signals. So, but we cannot understand the signals. So this device will an interface between us and the network signals. It is also known as LAN card or Ethernet card. We can also call LAN card or Ethernet card, and network interface card or network interface controller. There are many names. Okay. See, Ethernet card has a unique 48-bit address. Ethernet card, a unique 48-bit address. What is that address? This is the MAC address. Let's copy. This is a very unique address. Nowhere you will find the same address with any computer. With any computer. Like our IME number. So this is a 48-bit address. This is a 48-bit address. So here, octets. This is one octet, 2, 3, 4, 5, 6. 6 octets. 6 octets. So 6 octets, and each octet 8 bits. That is the reason we call 48 bits. 8 bits. Each octet 8 bits. Each octet is 8 bits. See, this is octet. I said this is the octet. This is octet. So each octet 8 bits. So these are 6 octets. 6 into 8, 48, right? 48 bits. Bit address. This we call 48-bit address. Okay. Next. So Ethernet card speed. There is a network. So network means speed, right? So what is the speed? One second. So speed. So there are different uh, types of different speeds available in the market. Ethernet. Ethernet. This is, sorry, Ethernet 10 Mbps. Usually 10 Mbps. Ethernet. So if you, I think, 1 second, ncpa.cpl. See, this is 100 Mbps speed. And what is the speed? 100 Mbps. Oh, my system configuration is more. If you see the speed, you can find the speed. But in the market, I mean, the different types of speeds, 10 Mbps and fast Ethernet. This is Ethernet speed is 10 Mbps speed, and fast Ethernet 100 Mbps. Okay, and gigabit Ethernet is 1000 Mbps. These are the different speeds. Usually our computers, laptops, this is the server which I'm showing, which I'm using. The machine is the server. So that is the reason we are seeing 100 Mbps. But usually in all personal PCs, laptops, all are 10 Mbps. And in coming high-end laptops and desktops is usually 100 Mbps speed. And gigabit Ethernet. This is 1000 Mbps. Usually servers having this Ethernet cards. Based on the card, based on the NIC card, the network speed will be there based on the Ethernet card. This is hardware. This is hardware. For example, many Ethernet cards are available. For example, fast Ethernet card. See, this is fast Ethernet card. You can see the Amazon 32-bit GB. So see the shape and working, everything is same, only speed. That's it. Only speed. Okay. So coming to media. What is media? Media is not news channel. We thought media is news channel, right? Sorry. Not news channel. Media means, see, media means cable. Simple. Means cable. Media means cable. So without the cable, we cannot connect it together, right? In the network, so all the PCs are connected together using with the help of router, switch, hub, whatever. But without the cable, can we connect? We cannot, right? So we cannot use Wi-Fi in the office network. See, with outside of office, without the cable, we are able to connect the devices or Wi-Fi, right? But in the office premises, in the office network, in the private networks, we cannot connect the network without the cable, right? See, media means cable. Okay, this is media. The purpose of media is to transport bits from one machine to another machine. Transport bits. So that is called media. Media is transport bits from one machine to another machine. Okay, so there are cables, cable types. There are types of cables. What the types of cables? Cat, Cat S. There are Cat S cable and Cat S E and Cat 5. Sorry, Cat 5, Cat 6. Okay, these are the types of cables. Types of cables. You can see the so cable is also same, not different, but the based on the speed, based on the cable, the speed will decide. So cat and cat S and cat 5 and cat 6. There are many. See, cat 5e, cat 6, cat 7, and cat 7 are also there. So this is the cable, same cable, but there are the data bits speed is more. See, for example, this is the example. Cat 5 can transport, the speed limit is 100 Mbps. Cat 5e 1 Gbps, Cat 6 1 Gbps, and Cat 7 10 Gbps speed. So the data transport, the data travel speed is more, like our vehicles, right? So if you see electric scooter, the maximum speed of 70, 60 kilometers. If you see the petrol scooter, 120, 150 or something, right? Based on the vehicle, the speed will decide. Like based on the cable, the speed will decide. So there are many types of uh, uh, see, cat 1, cat 2. We are not using this cat 4, cat 5 onwards we are using. Now we are not using cat 6 also. From cat 5 to see up to cat 8.2. These many types of cables we are using right now. But most of the cases in organizations, cat 5 is using cat 5 or max cat 6, cat 5e. These three only we are using in any organizations. So if you see the data centers and cloud, all they're using this because servers needs more speed, network speed. So usually more speed of cables uses at servers, not PCs and desktop machines. Okay. So coming to network devices. So I think this also we have discussed yesterday, right? Network devices. So these network devices we call switch, router, firewall, and hub. I'm not going to tell hub because hub nowhere is using hub. So these are the network devices, primary network. There are many network devices, but the basic network devices are switch, router, firewall. Okay. So switch, what switch do? Switch is used to okay. What switch do? Switch is used to connect it together to communicate. To communicate, what switch do? Switch used to do communicate the computing devices together. Switch used to do, it is in a hardware device. Switch is in a hardware device. First of all, that centralized communication between wide devices connected with a LAN. That is called switch. Switch is a hardware device. That centralized communication. See, this is a centralized communication. If you want to connect from PC 1 to PC 5, the The command center is here. So you can directly going to PC5 because this is a centralized communication between wired devices. Wired devices means connected. The devices are connected with a cable, that is called wired device. Wired device in a within a LAN. So it is a hardware device that centralizes the communication between wired devices connected within a LAN. Next, this wireless access points. So Wi-Fi, we call Wi-Fi. It is a hardware device that centralized communication between wireless and wired device within a LAN. So in wireless also, if you're sending a request with a wired device or without a Wi-Fi device, the the functioning is same. So if you type google.com in wired device, and also if you yeah, here the request will go to Wi-Fi router. The Wi-Fi router take the request to the outside. Wi-Fi router take the request to the outside and get the response from outside. I mean, outside means WAN, and forward to the particular device whoever requested that request. Okay, so that is the switch and router. What is a router do? Router is a device. Router is also a hardware device which enables a communication between two or more different logical networks. So router usually do, for example, one second, delete. Yeah. So let's say this is also switch. This is also one network and switch. This is network one. This is network two. Okay. So I want to communicate these two networks. I want to communicate these two networks. So network one having some PCs. So all the pieces connected switch here. And network two, there is a one more switch. All the computers connected in this. Okay. So I want to communicate from this network, from network one, PC1 to network 2, PC5. So this PC want to communicate, this PC want to communicate this PC. So how is it possible? Yes, is it possible? If you place a router here, router, router, and you can connect this switch to router, and from this switch to router. Then these both networks will communicate each other. Now, from this network can communicate this network. From this network, network 2 can communicate network 1. Network 1 PCs can communicate network 2. So vice versa, these two networks will communicate vice versa with the help of router. With the help of router. So router is a device which enables the communication between two different different logical networks. Next, firewall. What firewall do? It is a device which protects the network from unauthorized access. It allows and denies the network traffic based upon the policy configured. So what firewall do? Okay, fine. This, one second. Okay. One moment. Okay. So if I want to share the internet to both networks. So to connect the internet, we need the internet connection. So this is the internet. Okay. This is the internet. Internet. Okay. So because we are all needed a public network, because there are a lot of things in the public network. So in our day-to-day activities, without the public network, I guess, I feel we cannot work on anything nowadays. Without the public network help, we cannot do anything, because for anything, even we are in a training also, we are using public network to know things, to get the things. Okay. So all this network 1, network 2 needs public network access. I mean, internet or WAN. Let's use WAN, not to use our public network. Okay. So definitely we need a connection. So what router will connect the public network? So of course, so what router will do? Router will share the public network to both networks. So hence everyone get the internet. Everyone get the internet, public access. So everyone can able to access public network with the help of router. That's fine. See, you're on a private network. You're on a private network. That the data is more value. Am I right? So data is more value. If someone from public network coming into our network and sniffing the our devices are um, are grabbing or whatever, thefting any data from our network, there are chances, because there is no security. What router is do? Router is to share the network, enable the communication, enable the communication. So this is public network, this is private network. So router used to enable the communication between two networks, but router doesn't have ability to stop thieves. We just to make you understand, I'm using layman language, thieves. So we need a main door should be locked, then only thieves will not enter into our home. So in our public network, to protect our public network from the public network, because in the public network many people are there, you cannot uh, tell these are the good people, these are the bad people. So uh, you cannot assume that they are good. So across the world, many different people are in the public network, right? You never know who will come inside our network. So that is the reason we need a firewall. How firewall looks like? Firewall. Let's say firewall. See, this is the firewall. See, this is a firewall. Let's say, let me copy the firewall image. Copy. So what I'll do, the firewall has the ability to protect our network. The firewall is ability to protect our network. So I place the firewall between public network and my router. So what are the requests coming from? If anyone trying to access our network, the firewall will stop them. based on the rules. Firewall is not robo. We need to define the rules. Based on rules, the firewall protect our network. Who will define these rules? We. We define the rules. We'll create the rules in the firewall. So firewall acts based on the our rules. Security guard. If I say security guard, don't allow anyone inside. That is only one rule I pass the security guard. For example, at my home or at my office. So he will never allow anyone further until unless our approval. So the firewall will also do the same. Never allow anyone until unless I define the rule. For example, I want to um, uh, I want to deny the facebook.com site. So I can do that in the firewall. So no one will get Facebook because maybe because of from the Facebook, fewer hackers are coming inside our network. So I stop the Facebook. I stop the buffering videos. So and also not only protecting from our public network, from public network to private network, and inside also there are firewalls. Inside also we can place the firewalls in the real time. Inside also there are firewalls like here inside. So why we need inside? Why we need inside? We don't have any issues inside. There is no security threats. But why we need in a firewall inside? Because we can we can reduce the unnecessary uses. We can reduce the unnecessary uses. For example, this PC in who are sitting on the in PC one always watching YouTube. So hence the company is getting more bill, public network bill. No one will give free, right? We need to pay like current bill. So I can stop the YouTube here. So no one will access YouTube. And for example, this is a accounting department, accounting, finance. Okay. And this in this network employees, accounting, finance, HR. Okay. And this network employees, dev team, development team, admin team, and QA team, many teams are on this LAN. So we all know that the accounting, finance, HR team has a very crucial information which should not disclose to anyone, right? In the company policy. So what they mm, uh, do, they create they configure a firewall in the network so that other employees cannot access their data. Of course, they are in the same network, but able to communicate. But if anyone trying to access their data, crucial data, they cannot access because there is a firewall. So in-house, inside also, in real time, we use firewalls to protect the network and get reduce the unnecessary usages. We use firewalls inside the firewalls. So these concepts will discuss in CCNA more. So here one thing I would like to tell you, see the cable. I I told you cable is a media to connect PC to switch, switch to router, router to internet. So all connections uh, via media, right? So there are types of uh, cables. What is that? One is straight cable, straight through cable, straight through cable, and cross over cable and roll over cable. These are the types of cables. Cable is one, but if you make a cable straight through cable, crossover cable, rollover cable. See, water is same. If you pour the water in glass, you will see in a glass shape. If you pour the water in some other shape, you will see the water. Like cable is same. See, cable types are here based on the speed. Cat 6, Cat 5, Cat 7, lot of. But these are types of cables. So what is straight? Let's show you how the straight versus cross versus rollover. So where we are using this kind of cables? First, let me explain where we are using these cables. For example, straight cable. So straight cable, these are all networking. It's a good to know. Straight through cable. So straight through cable generally used for connecting two devices of different types. So this cable uses to connect to different devices. Connect different devices. So this cable used to connect different types of devices. For example, PC is a device and this is switch, different device. So both are different devices. So we use straight through cable to connect these two devices. The devices are not same. This is PC, computer, and this is switch. So we use straight cable here to connect. This is straight through cables. These are straight through cables. So next. So crossover cable, generally used for connecting same type of devices. Same type of devices. Same type of devices. For example, see, if I connect switch to switch, this is crossover cable. Or router to router, we use crossover cable. This is crossover cable. Same type of devices. If you want to connect same type of devices together, we use crossover cable. And rollover cable, generally used for connecting router console port to a computer. Okay, to connect router console port from computer to computer, whatever. For example, if I want to configure a router, so without configure router, if you simply connect both networks, the both networks will not communicate. We need to write a routing table. We need to write a routing table in the router. So how you will write the tables, how you will write the communication of network 1, network 2 in the router. So you need to connect from a computer to configure the router, right? To configure the router, you need to connect some from computer. So this is PC. From this PC2, I need to connect router. We need to connect a router to configure the router. So in that case, I should use crossover cable. Sorry, rollover cable. I need to use rollover cable to configure the router. Okay. So this is where we need, the straight cable we need, where the crossover cable we need, where the rollover cable we need, right? So cable is one. Based on the speed, we can see media cat S, cat SE, cat 5, cat 6. There are many types of cables based on the speed. And to connect devices, we need straight through cable. If you want to connect a different devices, crossover cable to connect the same devices, rollover cable to connect a router console port. Okay. So that's all for today, guys. Any questions? Please feel free to ask me. Any questions? Okay. Thank you all. Thanks for joining. Have a great day. See you tomorrow at the same time.